So we go to posteriori analysis. So that is by means of computing the actual air supply um, and the excess air from unknown flue gas. So produced during the product combustion. So yung before that I have discussed, so that is priori, so that it means that from the start of the combustion, so we can even we predict or we calculate what will be the product of the combustion. So after the before the combustion takes place, so we predict it already what will be the product of combustion. Now this time posteriori is in uh, determining the fuel ratio, actual air fuel ratio based on the product of combustion. So kung ilan ano na yung na-produce niya. So this is by means of taking the product by means of yung dry product test. So that which is coming from the testing center, no? So if you can see yung mga testing center that we have here sa motorcycle and also four wheels, two wheels, so you will also notice that nilalagyan nila ng smoke test. We have the smoke test pala, no? So we have the smoke test to determine what it will be the product content, or so how many percentage of the carbon content, CO2, H2O, or the product of combustion. So if we have that data, so we can predict now the stoichiometric air fuel ratio that is being used by the combustions. So ito yung purpose ng posteriori analysis. So from product of combustion, so we have your flue gas. So if we determine what will be the product of that one, we may able to predict what will be the air fuel ratio, your mass of air, and also the mass of your fuel. So we able to get the air fuel ratio and also how much is will be the excess air of during the part of the combustion. Now, we have an equipment used to analyze that, what is yung tinatawag na ORSAT analysis. ORSAT analysis gives a product of molar analysis in the product basis on a dry basis. And we have here the equivalence ratio, or sometimes in other book it is named as dilution coefficient. So that is the ratio of actual air fuel ratio, stoichiometric air fuel ratio divided by the actual air fuel ratio. So that is the equivalence ratio. So later on we will will show you during the calculation what will be the importance of using this one. Now I have here the table, so properties of fuel, no? So mapapansin nyo, we have different types of fuel here, starting from gasoline, no, going to hydrogen. Okay, so we have light diesel and so on, and we have the corresponding chemical formula of each fuel, no? So mapapansin nyo din, we have heavy diesel, and we have your light diesel. So you have the chemical formula, so that will be C12.3H22.2. Okay, so and we have also the corresponding molecular weight and the heating values of each fuel, no? And we have your higher heating value and also the lower heating values of each fuel. Now we have here the stoichiometric air fuel ratio, okay, and we have here the fuel air ratio. So mapapansin nyo, we have air fuel ratio and fuel air ratio, so which is S, so that is in terms of stoichiometric. Now we have your octane number, and we have the heat of vaporization of each fuel, and we have also the cetane number. So this is the corresponding data of our fuels. Now to determine the actual air fuel ratio from the given ORSAT, so we have your step 1, no? Write out the actual reaction. So we're going to assume 100 moles of dry product to eliminate the long decimals. So again, we have your fuel plus air, and we have your dry products plus your H2O for your ORSAT analysis. Now, we're going to go to step 2. We're going to solve for the actual air-fuel ratio on the molar balance. So we have your air-fuel ratio, that will be the moles of air, molecular weight of air, moles of fuel, then molecular weight of fuel. Now, going to step 3, solve for the stoichiometric air-fuel ratio by doing the stoichiometric calculation for the given fuel. Now, we have here sample problem, hydrocarbon of fuel. So, mixture CXHY. So, we don't know what type of fuel that is being used. Now, burns with air, giving products with a dry molar analysis of 11% CO2, and we have 0.5% CO, then 2% CH4, and we have 1.5% H2. Then also we have 6% of your oxygen and 79% of nitrogen. So determine the theoretical percent air that is being used and assume equivalence ratio of 0.6. So that will be the ratio of actual air fuel stoichiometric ratio, stoichiometric air fuel ratio divided by the actual air fuel ratio. So let's start with the solution for this problem. Okay, so I'm going to start here. We have the percent, no? So we have your percent theoretical. So that will be your air. Okay, so that will be equal to 100%, no? Plus your excess air. So this is common. We have the equation. Now we can rewrite our air fuel ratio, which is equal to your, so this is actual, no? Stoichiometric air fuel ratio, that will be multiplied by 1 plus your excess air, no? So our excess air, air, so that will be equal to actual air fuel ratio divided by the stoichiometric air fuel ratio. So if you're going to rewrite the equation, that one, so that will be minus 1. So that will be the excess air. So if we're going to derive the equation, so we will end up at this type of equation. Now, solving for the actual air fuel ratio, so we're going to write again the equation. So again, we have your fuel, no? Fuel, we have plus air, then we have the product. Okay, so the products, then we're going to add your H2O here. So since we are in the actual, no? So we can rewrite now our equation since we don't know what is the fuel for this one. So we can write CX, no, Y. So since we don't know what is the moles of this one, so we can write that will be A plus your O2 plus 3 so we have 3.76 of your nitrogen. So for the product, we have that will be 11 of your CO2 plus that will be 0.5 of your CO. Okay, so this is your product of combustion, plus 2%, so that will be 2 of your CH4, plus that will be 6, no? 6% of oxygen. So we have your 6 of your oxygen, then plus that will be 79%. So 79% of your nitrogen, so that will be N2. Then we're going to add your H2O here, so that will be plus. Since we do not know what is the value of that one, or how many percentage of that oxygen H2O, so I'm going to write here unknown letter D for our H2O. So we have for your H2O. So let's go, since we have now the combustion formula, so we can perform the balance reaction. So performing the balance reaction, so we're going to start with your nitrogen, no? So let's do your nitrogen. Let's go for your nitrogen. So for our nitrogen here, so what we have here is your 3.76. So that will be your A, that will be multiplied by A. So that will be 3.76, no, times 2. Okay, so that will be times 2. So that will be times 2. So on the product, we have here 79, no? 79 times 2. 79 times 2. Okay, so we can solve now for the value of A, which is 21. Okay, then let's go for the hydrogen. Now for our hydrogen, we have here, you will notice we have hydrogen in this one and this one. Okay, so yun lang. So that will be, so it is unknown, so I'm going to put here a letter Y since it is represented by Y. So that will be equal to, so Y, that will be multiplying by 1, okay? Then it will be equal to, on the other side, so for hydrogen, we have 4 times 2. So for the product, we have 4 times 2. Then we have also here, that will be hydrogen coming from your H2O, which is added from here. So that will be plus. So meron pa pala tayong dagdag doon. That will be 2D. So, also we have, so this would be 2, 4 times 2. Then, okay, I forgot, meron tayong na kalimutan na isa pa. So we have your 1.5 for your hydrogen, this one. So this is, we're going to add the hydrogen here. So I'm gonna add plus the 1.5, no? 1.5 for your hydrogen. So I forgot this one, sorry. So forgot this one, 1.5% of hydrogen. Okay, so reviewing that one, so it has no corresponding value here for nitrogen. So we have here 1.5. So I'm gonna multiply this by 2. Then I'm gonna add your 2 times your D. 2 times your D. Okay. Since we don't have the value of your D to solve the value of Y. So again, let's move on. So let's go to the oxygen. So for the oxygen, we have 2 times your A. So that will be equal now to 2 times your 11 on the other side for the product. Then I'm going to add with that will be your oxygen, that will be 1 times 1.5, 1 times 0.5. Then going to add your oxygen on this one, 2 times 6. Then adding the value of here, we have D. Okay, so D times 1. So since we have the value of your A dito, so we can substitute that 1 so para makuha natin ang value ng D. So we have now 2 times the value of A, which is 21. Okay, rewriting that one, so we have 22 here plus 0.5 dito. Then we have 2 times 6, that will be 12. And we have here your D. So finally, solving that one, so we have the value of 7.5 for the value of your D. Then we can substitute this one here. So we have now the value of your Y, which is equal to, that will be 11, or this one, 4 times 2 plus, that will be 8 plus this one, 1.5. So we have 11, no, plus 2 times 7.5. So we have the value of your Y, which is equal to 26. So let's continue. we try to solve now for the value for the carbon. So, magkaroon tayo ng value nito. Okay, so for the carbon, so what we have here is your x, no? So I'm going to write it here na lang. So for our carbon, so what we have here is x, no? Corresponding that we will multiply by 1. So on the opposite niya, so we have that will be 11, no? So that will be 11. Then we have 0.5 plus 0.5 plus we have here your 2. Okay, so that will be 2 times C. Then we have here, okay, so yun lang. So we can solve the value of your carbon is equal now to, this is 11 plus 2, that will be 13. So plus 0.5, so it will be 13.5. So that will be the value of your x. So meron na tayong y, so we can identify the type of fuel yung gagamitin natin. What I mean, what type of fuel that is being used during the combustion. So, writing the chemical equation of the fuel, so what we have here now, the type of fuel that is being used dito sa combustion. So, we have, so that will be C, no? Yeah, that will be C. So, your X value, okay, for the X value, that will be 13. Will be 13.5. Then you have your hydrogen, which is the value of your y, so it will be 26. Then plus the value of A, so that will be 21, no? Then multiply by your O2 plus 3.76. Then you have your nitrogen. Then for the product, we have 11 CO2 plus we have 0.5, that will be CO plus 2 CH4, then plus, then I'm gonna plus so that will be 2 CH4, then plus 6 O2, then plus we have your 79 for your nitrogen, N2, then plus the value of your D, so the value of D is 7.5. 7.5, so we have for the H2O. Okay, then we can further expand yung equation natin, or we can further rewrite this one as we have C13.5, then we have H26. So let's distribute this on 21. So that will be 21. We have your O2 plus 3.76. So that will be 78.96. So this will become 78.96 for your nitrogen. Then for our product, we have 11 CO2 plus 0.5, we have CO, then plus 2 CH4 plus 6 O2 plus 79 nitrogen plus 7.5, we have your H2O. So let's do solving the stoichiometric air fuel ratio. So we have stoichiometric, that will be air fuel ratio. So that will be equal to the mass of air divided by the mass of your fuel, then equals to moles of air, then molecular weight of air divided by the moles of fuel, then the molecular weight of your fuel. So this is equal now to moles of air. We have so that will be 21. So that will be 21 times 32 for your oxygen, no? So this is 21 times 32. Then plus, we have for your nitrogen, that will be 78, no? 78.96 times, that will be 28, okay? Then for the moles of fuel, again, we're going to assume this is 1. So I'm going to use here 1 moles of fuel. Then I'm going to multiply this one by the molecular weight of your fuel, that will be 13.5. No? So 13.5 times 12. Okay. Then I'm gonna add the for 26 for your hydrogen, so that will be 26 times 1. So I'm gonna close parenthesis this one. So this will become kilogram per k mole. Okay. So using our calculator, so from here our stoichiometric, so stoichiometric air fuel ratio now is equal to that will be 15.33. So this will become kilogram of air. This will be kilogram of air per kilogram of your fuel. Then we all know that the actual air fuel ratio, so this is equal to your stoichiometric air fuel ratio times to 1 plus your excess air. Then we can write our excess air is equal to actual air fuel ratio divided by your stoichiometric air fuel ratio minus 1. No? Then we have your stoichiometric ratio of equivalence ratio. So this is equal to stoichiometric divided by the actual air fuel ratio. Okay, so we have now your stoichiometric and actual. So since we need to determine the theoretical air use, okay. So since kailangan natin makuha what will be yung actual air, excess air, theoretical air, so determine the percent of theoretical air use. Okay, so since we have here your ratio for equivalence ratio, so we can rewrite yung equation ng equivalence ratio. So that will be, since we have already the stoichiometric, we can rewrite this one as our actual air fuel ratio. So that will be equal to stoichiometric air fuel ratio divided by the equivalence ratio. So our actual air fuel ratio, so that will be equal to 15.42 divided by the 0.6. Okay. So our actual air fuel ratio now is equal to 25.7. So that will be the kilogram of air, kilogram of your fuel. This is now our actual air fuel ratio. Since meron na tayong value for stoichiometric, then we have your actual air fuel ratio. So we can solve now the excess air. So from here, we can substitute your value of your excess air. So we have your actual, so that will be 25.7. So that will be kilogram of air, then kilogram of your fuel, then divided by, that will be divided by your stoichiometric, so that will be 15, 15.33. So this is kilogram of air, kilogram of your fuel. So minus 1, okay, so that will be minus 1. So we have now the value of your excess air. So we have the value of 0.67. So, or let's say, this is 67%. Okay, so again, so let's have a quick recap, no? So from here, we start by solving the air fuel ratio. So we write the chemical equation. So we have an unknown type of fuel, which is CXHY. Okay, so that will be burned. Okay, so within giving products, so that will be 11% CO2. So sinulat din natin yun. Then we have your 0.5, no? So 0.5 for the other properties, and 2 and 6 and so on. Then afterwards, you do mass balance the reaction. Okay, then we try to solve the value of A and D and Y and X. Then writing the after balancing the equation, so writing the chemical formula. So we able to determine yung what type of fuel that is being used. That will be C13.5H26. Then writing the chemical equation, the combustion. So finally, we have C13.5H26 plus, that will be 2102, 78.96. That it will be your air and fuel. Okay, and we have your product of combustion. So since nakuha natin ng value ng D, so that will be completed already. Now, solving for the stoichiometric again, so that will be the mass of air, mass of fuel. So we able to determine, since we have already the properties ng type of fuel, and also we able to determine the value of your A for your air. So substituting that one, we able to determine the stoichiometric, no? Then since the problem also given the equivalence ratio, that will be the ratio of actual stoichiometric air fuel ratio divided by the actual air fuel ratio. So we able to establish your air fuel ratio, that will be 25.7 kilogram of air, kilogram of fuel. Then from here, equation of your excess air, so substituting the value, and finally we able to achieve the value of 0.67 or 67, or we have 67% of your excess air. So okay, that's it.